So hello everyone, John here. Well, in this video we're going to talk about trigonometric functions. And trigonometric functions, you must have heard about them: sine, cos, tan, cosecant, secant, and cot. So let's first start with an acute angle theta. So an acute angle theta means that basically you have a triangle like this. I tried to do a straight line, but it didn't work out. So you have a triangle like this, it's really not easy to draw straight lines here, but suppose this is a triangle. Well, this is theta, and then in this triangle, this thing over here, this side over here is called hypotenuse. This side over here is the opposite side, because it's the opposite on the opposite side of theta. So opposite, and this is the adjacent side to theta. So this is adjacent, opposite, and hypotenuse. And let me try this, see how this works. Now in this case, theta is an acute angle. An acute angle means that theta is less than or equal to 90 degrees, or pi by 2. So if theta is less than or equal to 90 degrees, it means that it's an acute angle. For an acute angle, you have these relations basically over here. You have sine theta, you have cos theta, you have tan theta. And sine theta is always in case of an acute angle like theta, it's always opposite by hypotenuse. So OPP means opposite this side, which is basically let me see, right, this is basically the opposite side, and this is the hypotenuse. Cos theta is always adjacent by hypotenuse, and tan theta is always sine divided by cos, so it's always opposite by adjacent, which is correct. This is basically always sine theta by cos theta. And then you have basically cosecant theta, CSC theta, which is 1 divided by sine theta. So 1 divided by sine theta is the reciprocal of opposite by hypotenuse, which is hypotenuse by opposite. And we have secant theta. Secant theta is always equal to 1 divided by cos theta, which is always equal, which is 1 by cos theta. 1 by cos theta is the reciprocal of adjacent by hypotenuse, which is hypotenuse by adjacent. And you have cot theta, which is always 1 by tan theta. So 1 by tan theta is basically the reciprocal of any of these ratios. So it could be the reciprocal of this one, which would be cos by sin theta, or adjacent by opposite. So this way, if you have angle theta is this in this triangle, and then if you have for example, if you have let's say sin theta here, you know that sin theta is, for example, they say sin theta, they give you the value of sin theta as 1 by 2, and you know that the opposite is, you have the value of this, then you can basically calculate the value of hypotenuse using this relation over shear. So that's in case of obtuse angle. So let me write this obtuse come on. Let's say 2. So it's an obtuse angles less than 90 degrees. Now, let's do another case. I guess we have no more space in here, so I need to do another layer in here. New layer, okay. I wanna hide this. So, if you had well, the definitions that we were talking about here, they don't apply to obtuse or negative angles. So, if you have an obtuse angle, the obtuse angle is basically larger than 90 degrees or greater than 90 degrees. So it would be something like this. Basically, you have, if you had an angle, let's say this is x and this is y, and if you had an angle something like this, then this is an obtuse angle because it's greater than 90 degrees. So it's 0 and 90, it's around, let's say, 135 degrees. And in this case, let's say P is on this line, on the terminal line. If this is P, x comma y is the x and y coordinates of P, and if this is r, the length of this, basically the value of OP. So if this is O, if this is R, so if OP, the absolute value of OP is equal to R, and if P is a member of this line, is on this line, then the definitions that we talked about about the acute angles, they don't basically apply here. so then you basically would have to kind of change them so that you get the right value for your sine, cos, and other ratios. So for general angle theta in standard position, we let P with coordinates x and y be any point on the terminal side of theta. So this is the terminal side of theta, and P is basically a point on this line on the terminal side of theta, and R is the distance OP. So the distance between O and P is, we've called it R. Then you have to basically define your ratios as these. So you had sine theta. So sine theta in this case is y by r. It means this is your y. So this is your y, and this is your x. So if this is your y and this is your x, no matter where you get this point, wherever you choose this point on this line, if the point comes, for example, over here, then this is your y, this is your x, and so on and so forth. And you can get closer to O or get as far from O as you would like. So basically sine theta in this case would be equal to y divided by r. I'm sorry, y divided by x. And no, I'm sorry. Made a mistake. Not correct. It's basically y divided by r. And cos theta is x divided by r, or this distance divided by r, basically this distance. Tan theta would be basically sine theta by cos theta. So it would be y divided by r divided by x divided by r. It would be basically y divided by x. And then you have the other ratios as well. You have cosecant CSC theta is equal to basically 1 divided by sine theta, which is r divided by y, the reciprocal of this. Secant theta is equal to 1 divided by cos theta, which is the reciprocal of this, which is r divided by x. And you have cot theta, which is the reciprocal of, which is 1 by tan theta, which is cos divided by sine theta, which is x divided by y. So that's basically what happens here. So I'm basically done with these. So I hope you like this video. I'll see you in the next video.